Hi, welcome to the Lab Flow 1406 workshop, which is conversion, factors, and problem solving. Today's objectives, when you finish this workshop, it is my objective that you all learn how to report a calculation to the correct number of sig figs. Please stop me anytime, unmute yourself or send me a message. I want to make sure that we complete these objectives. We are going to do during this session some practice problems. So before you start doing your quiz, you have the main concepts that you will need to complete that quiz. And also, we will go over all step by step. We will go over the report and make sure that you know how to make calculations with the correct number of sig figs. Also, measure dimensions to calculate the area and volume, and using conversion factors. Convert, in this case, it says between metric and other units of length. So by the end of the workshop, if you don't have all those objectives, I will stay after the session and I will answer all the questions. This is very important, not only to complete the report this week, but because you are going to need it for the whole semester. These are basic concepts. So basically, this experiment is all about measuring with the correct number of sig figs and make calculations. In a way, once you learn, this is very simple. So let's go over the write-up of the experiment first. So they are talking about the objectives, and then they give us a little background. I highlighted what I thought is important. Here it says, measurements involve two parts, the number and the unit. We cannot make a measurement without the other. It means anything. If you report, you are making a measurement and you say, okay, what is the length of that book? And you say 3. That is the number. But because in chemistry this is not math, 3 doesn't mean anything. Can be 3 meters, can be centimeters, can be inches. So that's why when we report any measurement, we need a number and we need a unit. If you get the habit of doing that, you are good to go. So the unit reflects what property is being measured. So if you are measuring length, you will have either meters or centimeters or feet. So you know you are measuring length. And the quantity here is the number. The number is very important for 2 reasons. The quantity and how precisely. So this concept is very important. If you ask me, what is the length of that book? And I tell you, for example, I will tell you 3 centimeters, right? And then another person will tell me 3.0 centimeters. So the units are the same, both are centimeters, but the number, one has 1 sig fig, the other has 2 sig figs. So the number is expressing the quantity, that is 3, and how precisely the measurement is. We will go over later, but the 3.0 is obviously more precise than the number 3. And it's indicating that the ruler that I used to measure the 3.0 has more divisions, is more precise than maybe another ruler that has less divisions. So the number, all this is just to clarify that the number indicates two things: how precise is the measurement and the quantity of the measurement. Another important thing before we go into how to calculate, how to round, is that every measurement will have some error. That is something that you probably know by now. We have two kinds of numbers, right? We have exact numbers and we have measured numbers. The measured numbers are always going to have an error. We cannot make an exact measurement. Always have the uncertainty, and that's where it comes to play all these experiments. It comes to play learning how many sig figs, what is the precision of the measurement, if I use an analytical balance or if I use a top balance, what kind of instrument I use. But the exact numbers, what are the exact numbers? Can be two things. Can be when you say how many books I have. Well, I have 2 books. That is an exact number. That is not a measurement. I am counting. And then there is all other kind of exact numbers, which we will see later, which is the conversion factors. The conversion factors are exact numbers. We are not going to take into account a conversion factor when we have to decide how many sig figs is going to have my answer. So when we say exact, these are conversion factors, is the other kind of exact number, we are saying that we think that we have infinite sig figs. What does it mean? Infinite sig figs has no error. Those are the exact numbers. But the measurement always is going to have an error. So let's continue and see what else they are trying to tell us. Here is talking about rounding. You can zoom in your computer if it's not clear. You can zoom in on your side. So let's look at rounding. What is rounding? When you do a calculation, we are going to look at that. Let's say you say, okay, 8.0 times 2. First of all, you are going to plug in those numbers in your calculator. 8 times 2, 16. The calculator will tell you 16. And then, because it's multiplication, in this case, actually, we don't, let's finish that and then we'll go. So then, this number has 2 sig figs. This one has 1 sig fig. So I have to round this number to how many sig figs? Let's see if somebody can message me. Because you plug in your numbers, right? 8 times 2, 16. 2. Okay, so here, 1, Carissa. Yes, I received different messages. One says that I have to round this number to 2, and the other says to 1. The correct number is 1, but we will go over later. Why is 1? When we are doing, when we have to decide how many sig figs will have our answer, first thing we have to do, look at what kind of calculations is done. In this case, I'm doing multiplication. It's different if I do multiplication or if I do addition or subtraction. Let's look at this one. This is multiplication. When I calculate and I do a multiplication, I have to put the number of sig figs of the lowest. Let's see, I have to look at how many sig figs has 8. 8 has 2. We are going to look at that later. Why 2? We will see that. 8 counts, all the digits count, and 0 counts because it has 0 after the dot. So then I have to look at each individual number in the calculation. So 8 has 2 sig figs. 2 has 1 sig fig. So my answer cannot have more sig figs than the number that has the lowest number of sig figs. In my case, this has 2, this has 1. So my answer has to have only 1 sig fig, which means that this calculator gave me 16, but I have to round it to 1 sig fig. How do I round that? Let's read this here that is highlighted. Once you know the correct number of digits to report, which we know it's 1 because the 8 has 2 sig figs, the 2 has 1. So we know, once we know the correct number of digits to report, we have 1 digit to report. Count the number of allowed digits starting from left. So I start from the left and I count 1 and I make a little line here. Then it says, then the next digit is the first digit to be dropped. That means that 6 is going to be dropped. But how I'm going to drop? I cannot say 1. This is not a round. If I have 16 books, I cannot round it to 1. I have to put a number after. So let's look at what it says here. If the digit dropped, to be dropped, which is the 6, the one is to the right of the line. If the digit to be dropped is less than 5, do not change the last retained digit. That means if I have to write 14 to 1 sig figs, if I have to do that, then I do this and I round it to 10. But because I have a 6, if the digit to drop is less than 5, we don't change the last retained digit, which is the 1, and drop all the following digits. If the first digit to be dropped is equal to 5 or greater, we increase the number. So we look at what is the number. We made a line, we need only one sig fig, and the next number is 6, is 5 or greater, which means I have to increase the last retained digit by 1 and drop all the following digits. In my case, because I have a 6, I am going to round to 20. Any questions? I had to add a 0 because I have to keep the value, to hold the place value of the number. We will do more practice. So this is about rounding. We are going to do that and we are going to practice. And here there is an example. Round the number 1662 to 2 digits. Okay, so how do we do this? We write 17.62. And it says the first digit to drop is 6, because exactly, awesome, Ken, excellent. So what do? We draw a line because we count from the left, right? And it says 2 digits. So we count from the left, the 1 and the 7, and we draw a line. And then we look what is the number to the right of that line. We have a 6. It's 5 or greater. That means I have to increase the 7 by 1. So I rounded to 18. Any questions there? Okay. And here it says, note that some large numbers need placeholders 0 when the digits are dropped in order to keep the same magnitude. For example, 6541 rounded to 3 digits, so we have 6, 5, 4, 1. And if I have to round this to 3 digits, I cannot cut. I have to keep the same magnitude, right? It's not the same if somebody owes me $654 or if somebody owes me $6541. So I have to keep that the same magnitude. In that case, we use placeholder zeros because the number of the right is 1. I don't have to increase the 4, so I rounded to this number, which is the same thing that happened up here when I had to round to 20. And that will always happen before the decimal. Before the decimal. We cannot, if we have a number with no decimals, we need to keep the same magnitude. So this is about rounding. Let's see what else comes. And then they are talking here about significant figures in calculations. So here it says the digits in a measured number are called sig figs. The sig figs are the digits that, as I mentioned at the beginning, are going to tell me what is the precision of that measurement. So the number of the measured digits, when I do a measurement, I count how many digits I measure. And I have to express that, as we learned in the previous workshop, depending on the scale of the instrument, depending on which kind of glassware we use or ruler. So the number of the measured digits in any measurement is called the number of significant figures. So as I said at the beginning, the significant figures, because it's hard to grasp that concept, basically is telling us the degree of certainty of that measurement. If I will have somebody that will tell me 3.2058 grams, I have 1, 2, 3, 4, 5 sig figs. And another person weighs the same thing and tells me 3.2 grams. Only 2 sig figs here. And here 1, 2, 3, 4, 5. So basically the 5 sig figs is telling me that its measurement is more precise. If I report it with the correct number of sigs, it's not that I'm writing the numbers of the calculator. So the first thing here, it says the first step in working with sig figs is to recognize how many sig figs are in a measurement. So they are good, these people, and they are giving us this table that you need to know. You can read it from the right up. You need to know, because without that, if you don't know how many sig figs has a number, you cannot perform a calculation. So the first thing is recognizing how many sig figs are present in a number, in the measurement. So let's review, so you remember, because the zeros seems to be the issue. When the zeros are left or the zeros are right, but it's very simple. The first one, here is the guideline. The first one, all non-zero digits are significant. So if they give us 1.23, has 3 sig figs, all counts, the 1, the 2, and the 3. And that's the easiest. Then, zeros between non-zero digits are significant. And that's easy as well. So look at here. We have 4.062. And there is a 0 in between two numbers. Who cares? We know we have to count it. So we are going to say 4 sig figs. And that's easy as well. Now comes the trouble. When people don't remember which zeros count and which zeros don't count. So let's pay attention. Zeros to the left of all non-zero digits are not significant, which means they are giving me 0.094, and they say they have 2 sig figs, because the zeros to the left, we call them leading zeros. The zeros at the beginning, they don't count. Here, they write the example 0.98, and they say it has 2. But what happens if I give you, which seems to bring confusion, 0.098? How many sig figs have this number? Somebody can message me. How many sig figs? Carla said 3. So Carla is counting this 0. Somebody else wants to tell me something. John said 2. John is not counting the 0 after the dot. And John is correct, because if we read again, it says zeros to the left of all non-zero digits are not significant, which means that that's why I brought this example, because it's not very clear in this one. You don't count, because they are not talking about the decimal point. They are just saying zeros to the left of all non-zero digits. They are not talking about this dot, so we don't count. So this number has only 2 sig figs. We don't count any zero to the left. Now comes the trouble again. We don't know when to count the zeros on the right. Zeros to the right, it says here, of all non-zero digits are significant only with a decimal point. So now is when they are starting to talk about a decimal point. So here they are giving us the example 5.60, and they are saying that 5.60 has 3 sig figs. Why? Because they are saying zeros to the right, which is this one, we call it trailing zeros, are only significant, which means we only count them if the number has a decimal point. And because the number is 5.60, it has a decimal point. So we count and we say 3 sig figs. But what happens if I give you the number, for example, the number 560? I look at the number and I say, okay, there is a zero here. There is a zero to the right of a non-digit number. Then I have to look. Does the number have a decimal point? No. Then I don't count it. So how many sig figs has 560? Only 2. So you can learn this and you are good to go. That's why here it says the number 560 has 2 sig figs. So the first thing you have to learn is to know if how many sig figs are in each measurement, in each number. Once you know that, you can jump into doing calculations. It's very different how you are going to decide how many sig figs you are going to use. When you do a calculation, your calculator will give you a lot of numbers and you will need to decide where to cut it. And the first thing you are going to do is what kind of calculation you are doing. If you do multiplication or division, is different than if you do addition or subtraction. In our case here, they want to start with multiplication and division. So here it says, if a calculation uses multiplication or division, the result, the answer, should have the same number of significant figures as the involved measurement with the fewest sig figs, which means that I have to look at the sig, if I'm doing multiplication or division, I have to look at the number of sig figs and then pick which is the number that has the fewest sig figs. And then my answer will have that exact same number of sig figs. That is only for multiplication and division. And they're giving us an example here. They're doing a calculation. And it says, report the result of the calculation with the correct number of sig figs. Okay, how many sig figs has 5.60? Somebody can message me and tell me how many sig figs are 3, Carissa. 3, perfect. So this number has 3. Very good. Then I look at the other number. I look at 0.98. How many sig figs are in 0.98? 2. Awesome. And how many sig figs are in 1.23? Exactly 3. So my answer will have how many sig figs? Which one is the number with a few? 2. Exactly. I look, what is the smallest number? Okay, the smallest number is 2. So my answer has to have 2 sig figs. And then you plug in, you do the calculation in your calculator, and it says your calculator gives you this number. It gives you this number. Okay, when you do 5.60, multiply by 0.98, divided by 1.23. And then the calculator will give you 4.461788, and a lot of numbers. Now, because we already checked the number of sig figs of each number, now we know that our answer has to have just 2 sig figs. And as we said at the beginning, we start counting from the left. 1, 2. And we draw a line here. Very good. But it's not the end there. We have to cut it there. But we have to look at this number. We have to round. We can round up or leave it as it is, or round down. So we look at this number. Is 6 is greater than 5. So then my answer would be 4.5. I have to round up this 4, and my correct answer will be 4.5. Any questions up to here? Okay. Addition and subtraction. So let's refresh. When we do multiplication, we look at sig figs as we did here. But it's a little different when we do addition and subtraction. It's a little different. We don't look at sig figs. We don't. Look at what it says here. If a calculation uses addition and or subtraction, the result should have the same number of digits past the decimal point as the involved measurement with the fewest digit past the decimal point. It's a lot of words, but let's see here. They are giving us this calculation, right? 4.062 plus 1.23 plus 560. For multiplication, I had to look at the number of sig figs. For addition and subtraction, I have to look at how many digits are after the decimal point. So let's look at the first number, 4.062. How many digits are after the dot? 0, 6, and 2. I have 3 digits after the decimal point because it's 4.062. I looked at the digits past the decimal point. 1, 2, 3. How many digits past the decimal point has the number 1.23? Somebody can message me. 1.23. Carissa said 3. 2. Carissa said 2. Sandy said 3. Yes. 2 is the correct answer. Very good. Sandy, I want to tell you something. I want to tell you counting the sig figs. We are counting the number of digits after the dot. So if I have the number 1.23, I look, where is the dot? Okay, here. How many numbers I have after the dot? So I count. 1 is 2 and the 3. I have 2 digits. Awesome. Thank you. So this 1.23, I'm not counting sig figs, I'm saying has 2 digits after the decimal point. And how many digits? Let's look now at the last number, 560. How many digits I have after the decimal point? Where is the decimal point? 0. Awesome. Exactly. The decimal point is here. So I have 0. So when I will do this addition, my answer cannot have more than 0 digits after the decimal point. I look at which number is the smallest. The first one is 3, the second 2, the third one 0. I have to have 0. So then let's look at the next page here. They say that the calculator here it says the involved number of US digit is 560, is exactly what we said before, with 0 digits. And from the calculator, we get this number. When you plug in that addition, you are going to have that your number is 561. Let's see. So it's 565.292. And then I say, because I already checked, for addition is not sig figs, we check the decimal places, we make a line here. And we do the same, round up or round down. Well, because after where this number is not greater than 5, my report, my answer will be 565. Any questions? I'm planning to stay also after the workshop, so you can ask me again or other questions. And now the write-up is talking about conversion factors. Conversion factors is very important. So when you leave this workshop, you will know how to work with conversion factors. Any measured property, it says here, can be measured in multiple different units. For example, length can be measured in units of meters or yards. And then we have to know how to convert one another. For example, I was born abroad and I measure my weight was always in kilograms. That is European system, is the metric system. But here in the US, it's pounds. So I'm weighting always the same, but they are different units. You can use different units to express any measurement. So they're talking, and we need to learn how to convert between one and the other. And it's very simple. And we are going to see several examples. In order to change from one system to the other, we need to know the equality. We need to know the equivalence between one and the other. So here, for example, the equality between two units defines the conversion factor or ratio of the two values. For example, here it says, okay, the equality 1 gram equals 1,000 milligrams. We need to know that. Probably in your test, or they will have to tell you, well, not this one, because you know milligrams. Of course, you know that 1 gram is 1,000 milligrams, but you need to know the conversion factors between, for example, pounds and kilograms, or between inches and centimeters. It's probably it's going to be given to you. You are not supposed to know. So you are going to use this equality to do the ratio. And here they are showing you that you can have 1 gram on the top, 1 gram. You can use this part, all what is to the left of the equal sign in the top, and whatever is to the right of the equal on the bottom, or you can do another ratio that is opposite, the 1,000 up and the grams down. And we are going to see examples when you need to use each one. When do you put the grams up, or when do you put the grams down? And that depends on what you are trying to obtain. But we will go over that. So the equality will give you the conversion factor. For example, we know that 1 inch equals 2.54 centimeters. That is the equality. And from here, I can do the conversion factors. I look at what is to the left of the equal sign, and I can put it up 1 inch divided by whatever is to the right, 2.54 centimeters. Or I can do the opposite, put the 2.54 up. So this is basically the write-up of this experiment. And here they are giving us some equalities. You need to know the equivalence. What is equivalent to what? 1 liter is and then from the equality, you can get either this conversion factor or the opposite conversion factor. And then they are telling us how to use the conversion factors in problem solving. So here's where we are going to learn how to use it. For example, they are giving us an example. They say, if a bed is 1.91 meters, right? What is its length in centimeters? So the first thing I know that I have to convert these meters into centimeters. First thing I have to do is, so I always write like an arrow here, and I say, okay, I have to convert meters into centimeters. That's the first thing. Then I have to find the equality. The equality is right here. 1 meter is 100 centimeters. And once I have that, I basically write 1.91 meter. How do I know which conversion factor I use? Do I put, here I have the equality, right? So I have to decide 1 meter equals 100 centimeters. So I have to decide if whatever is to the right of the equal goes up or down. How do I decide? I look to the right of the equal is centimeters, right? And centimeter is what I want, because if we look up, we want to convert this meter into centimeters. So then whatever has the centimeter goes up, 100 centimeters. So from this equality, I look at the units. Okay, to the right of the equal has the centimeter. That's what I want. It goes up. And what do I need to cancel? Whatever is in meters, because I don't want meters. I want it to cancel. Whatever needs to cancel out goes in the denominator. So that's how I do the conversion factors. Any questions there? Okay. So this is basically how you decide what to put up and down. You can have two conversion factors for any equality, but you are going to look at the units. I want the units, my answer, to be in centimeters. Okay, then 100 centimeter goes up. What do I need to cancel? I need to cancel meters. Okay, then whatever is next to meters goes down in the denominator. And that's how I do the conversion factors. Now, what else? Okay, so here starts doing the report, but before we do that, we are going to do some practice problems and to make sure that we are in the right page to do the quiz. Okay, let's do some practice problems to make sure that we know how to do conversion factors before we are going to do an overview of the report and make sure you know what to add there. Let's look at this first problem. How many minutes are in 2 days? It looks very, very simple. So what do you need to do first? Minutes into days. So you need to know the equalities. You need to know the relationship between minutes and days. There is not one direct, so you need two. So first you write what you know. So I always write 60 minutes equals 1 hour. Very good. What else I know? Because I have to convert minutes into days. What else I know? I know that 1 day equals 24 hours. So now I have all the equivalents on the side. This one is not necessary to be given because everybody knows that 1 day is 24 hours. So we start with what they give us. They are telling me 2 days, and I have to convert it into minutes. So I will use conversion factors. The first conversion factor, I need to cancel days. I have days here. I don't want to see it in days. I want minutes. But because the equality that I have with days is with hours, I will use this one first. And I want days to cancel. So I will write whatever is to the left of the equal, I will write down 1 day because I want day and day to cancel. And what do I write up in my conversion factor? Everything that is to the right of the equal, which is 24 hours. And now I need, what are the units that survived? I cancel days. What are the units of 2 days? If I have to report hours, thank you, Carissa, exactly. And do I want hours? No, they're asking me for minutes. So I need another conversion factor. I need to cancel hours and I want minutes up. So I look at my other equality. What is that I have to write down? I look at hours. I want hours to cancel. So I will do, in order to cancel, I need whatever is to the right of that equality, I need it down. And whatever is to the left of that equality, I need it up. So 60 minutes goes here. Hours cancel with hours, and the units that survive are minutes. So now I just, easy peasy, I plug in my calculator, 2 times 24 times 60. What number do you get? What number do you get when you do that calculation? Okay, thank you, Carissa. So we get 2880 minute. Very good. And now, what is it that we have to do? The conversion factors don't count for sig figs. We did multiplication. That means we have to count sig figs. If this would have been an addition or subtraction, we counted decimal places. But we count, at this time, we count sig figs. But all those sig figs from the equality, we think as having infinitive sig figs. So my answer has to have the same number of sig figs as our measurement, or 2 days. But because days is a number, we counted days, in this case, we are going to leave it exactly as it is. But if we have to round to 1 sig fig, if we have to, we will report it as it is, 2880 minutes. That is the correct answer for this problem. Just in case, if we have to round it to 1 sig fig, what would be the number? You can message me, just 1. 3,000, John, very good. Okay, if you write 3, you are not rounded. You have to once, because it's not the same, 2880 minutes that 2 minutes. Because you are left, everything that is left to the decimal point, you have to add 0. This is the hardest part. So if you have to round just this number to 1 sig fig, you are going to round it. You have to add zeros to hold the place value. This is rounded to 1 because if you are to the left of the decimal point, you have to hold the value of, you have 1, 2, 3, 4 digits. You have to have 4 digits to the left of the decimal point. Any questions on this problem? Okay, let's move to the next one. How many feet are in 2.34 miles? Again, we start with 2.34 miles. And I need to convert it into feet. So what do I know? I need a conversion factor. In order to have that conversion factor, I need to have the equality. What is that? What is the relationship between feet and miles? We know that 1 mile equals 5,280 feet. Now that you know this, tell me, what is going, 1 mile is going up or down? Message me. 1 mile, which down. Awesome, John. Exactly. I have to put what miles down because I want miles to cancel. And also because I want the other one, I want feet on the top. So that will be 5,280 feet. Very good. So the answer for this question is, if I plug in the calculator, I will have 1, 2, 3, 5, 5.2. Now I'm asking you, how many sig figs has to have my answer? Remember that this is a conversion factor and we count it as infinitive sig figs. So our answer has to have the same number of sig figs as my only measurement in this case. How many sig figs? 3, exactly. So I have to cut this in here. My answer has to have only 3 sig figs. So what would be, because the 5 is 5 or greater, I have to round up, what would be my answer of this problem? Somebody can message me. What? 124. That is close. Why is not right? Because you have to look exactly. You have to look, if you say 124, you are cutting the number of digits to the left of the decimal point. You have to have the same 1, 2, 3, 4, 5. You need to keep the place value to the left of the decimal point. So Carissa said 1, 2, 4. You round up, very good. But then you have to keep those, you have to add zeros because you have to keep the same number of digits to the left of the decimal point. Any question? These are the hardest when you have to add zeros. And then the last problem, let's look at it. What is the area of a rectangular park? So you have a park and that is 130 yards, 130 yards by 35.7 yards. And they ask you area, but they ask you in acres. So, and they give us the equality between square feet and acres. So how do we start? I wanted you to see this. How do we start? How do we calculate the area? The area of a rectangle is just the side, the width by the length. So we start multiplying. Exactly, very good. So we start by doing 35.7 yards times 130 yards. And when I do that, I get a number that is 4641. And then here I have yard and here I have yards. So it's going to be square yards. I will round this at the end, but for now, I have the area in square yards, but that's not what they want. They want in acres. Yes, I don't know if I'm pronouncing it right, but that's what they want. So what do? They give me the conversion factor here. So what I will do is they give me the conversion factor to feet. That means that I have to convert first to square feet, the yards into square feet. And then after that, I can change into acres. So now, 4641 square yards, I will convert it to feet. But be careful because it has a square. So I know that 3 feet equals 1 yard. But because I have square yards and I need square feet, I will put it twice. 3 feet and 1 yard. So the square yard cancel with the yard and the yard. So my units are going to be square feet. So now I plug in my calculator, 4641 multiply by 3, and again multiply by another 3. When I do that, I get a number that is 41769 square feet. Now I can use the relationship with acres. So I will go and I will say, okay, 41769 square feet. What do I need to write up? I will use this equality. So tell me, what should I put on the, I want my answer to be in acres. So what should I write on the top of my conversion factor? Yes, exactly, acres, very good. So I write 1 acre, and down I have to write all these numbers. 4, 3, 5, 6, 0 square feet. Square feet, the units cancel, and when I do this calculation, I get a number that is 0.958 acres. And now, the last part, to round. How many sig figs has to have my answer? Because everything is multiplication or division, I need to look at the sig figs. 3. Very okay. Okay, let's say 3. Because we have to look at which of these two numbers has the smallest number of sig figs. 35.7 has 3 sig figs. And how many sig figs has 130 yards? We remember that the zeros to the right only count if there is a decimal point. So 130 yards has only 2 sig figs because the 0 doesn't count. So my answer has to have only 2 sig figs. And then I looked at what is after the 5, and I have to round up. So my number will be 0.96 acres. Any questions? You can review and study that guide, that table that is telling you how to recognize how many sig figs are in each number, and the rest is easy. So now that we've seen some practice problems, we will move because we will move to the report. Let's go back to sharing the last part, but you are ready to complete your report with all this practice. Why not 3 sig figs for the last answer? Okay, for the last answer is 2 sig figs because we were doing the area of a park, and we had only 2 measurements. We started with 2 measurements. So we started with 130 yards, which is one of our measurements, and the other measurement was 35.7 yards. So we look at how many, it's a multiplication. So our answer has to have the number of sig figs of the measurement that has the lowest number of sig figs. 130 has only 2 sig figs. And 35.7, okay, you're welcome, John. Okay, awesome. That's the only reason. So now, quickly, we are going to go over the what do you have to do for your report. So the first part, let me see, is rounding. It's not very clear when you are going to do it, but I want to advise you that you have to round to 3 sig figs, because once you get there, it's not clearly telling you. So remember that the first part that is rounding, you have to round to 3 sig figs. Then there's some multiplication, addition, and let's continue. So we go to the report. Then you are going to calculate the volume, and let's see where is the report. Here. Okay. So this is what you are going to encounter, the report in a different format, but same thing. So as you see, it says rounding, and it's not telling you clearly that you have to round to 3 sig figs. If you read before, the write-up will tell you. So, but just in case, I want to advise you. So the first part of the report that you are going to encounter is basically saying they give you this number, and the students rounded value to 244. Is this correct? To 3 sig figs? We said that we have to write like that. 3, and we have to round up. Does it look correct to you? You can message me. Let's see what you wrote. Let me see what you wrote. Yes, awesome. It's correct because they round up. So here you can write yes, and they ask you to write again the value. Very good. And then you are going to see, let's look at another, let's look at this one. This is the number, and you have to round to 3 sig figs. Is that correct? This number, does it have 3 sig figs? Yes, it does. Correct, because the zeros after the dot, it counts. And some are correct, some are not, and that's what the first part of your report. Then is multiplication and division. We've seen that, so let's just look at the first one. They give you a multiplication. So you are going to plug in all those numbers, and you are going to, what number, why don't we do it one just now? If you plug in all those numbers in the calculator, what answer do you have? Just to practice. 0.1184 times 8.00 times 0.0345. You can message me. You can message me the answer when you plug in. Okay, so you got 0.0326784. Okay, and now tell me how many sig figs you need in your answer. In order to know that, you have to look at each of the 3 numbers. Let's look at the first one. How many sig figs has 0.1184? 4. Very good. How many sig figs has the second number? 8.00. 3. Perfect. How many sig figs has the last number? 3. It says 4. We don't count this. Yes, awesome. So 3. So our answer has to have how many sig figs? 3. Very good. So we count. The leading zeros don't count. So 1, 2, 3. We have to cut it here. And then we look at this number. It's a 7, so we have to round up. So our answer will be 0.0327. Any questions there? The rest is similar. Then let's go to addition and subtraction. You are going to encounter this. We said that for addition and subtraction, we don't count the sig figs. We look at the decimal places. So let's look at the first one. What number do you get in the first one, in your calculator? 13.45 plus 0.4552. What is the answer that you get from your calculator? You may message. Okay, 13 point, let me see, 9052. Okay. Now we have to round to how many digits after the decimal point. The first number has 2 digits after the decimal point, and the second number has 4 digits. We have to go to with the lowest number. So we have to have only 2. And we are going to cut this here, and we have to round up. So our answer will be 13.91. Does it make sense? Awesome. And then let's see what else you have to do. You have to calculate the area. So basically, they will give you the value of the length and the width, and you are going to calculate the same way we did it. This times this, and because it's a multiplication, they will give you also these values of another student that measures the same thing. And this you already seen. And then you are going to calculate the volume of a solid. Each person will have a different solid. But you know, if you have a cube or a block like this, the volume is going to be the height times the length times here the width. So they will give you the height, the length, and the width, and you just have to multiply the 3, and because it's multiplication, it's going to be counting the number of sig figs. And then what else you are going to do? Conversion factors, you know that 1 liter is 1,000 milliliters. And you will use the conversion factors the same way that we used it before. So this is basically, they will tell you this equality, and probably I think this part, I'm not sure is going to be included, but there is a section that is conversion factors, and you are going to do the report the same way we did it. For now, we are going to conclude here this week's experiment. I want to thank everybody for being here, and I will stop the recording and stay in case you have questions. Thank you again.